Okay, guys, we're going to talk about solving when x is part of an exponent and we have different bases. So in order to solve a problem like this, we have to have a similar base, okay? So if I look at 16 and 8, they don't have the same base. So I'm going to look at what number, how can I break down these numbers and write it as a base and an exponent so it would be the same. And if I look, I know that 16, I could rewrite 16 as 2 to the fourth power. And 8, I could write as 2 to the third power. Okay, so I have changed nothing so far. I'm just rewriting those numbers to have a similar base. And now 16, which is 2 to the fourth power, is still being raised to the x plus 1 power. So it should look like that. And 8, or 2 to the third power, is still being raised to the 2x power. So it looks like this. Now, what happens here is that since they have the same base and we know that they're equal, that means also that the exponents are equal. Okay, if the bases are equal and the whole thing's equal, then the exponents have to be equal. So what I'm going to do means I don't have to worry about the bases. I'm just going to take what's in the exponents. Again, we can only do this if they have the same base. Notice they both have a base of 2. And then over here I have 3 to the 2x power. And now I'm just going to solve like I would solve a normal equation. So I am going to distribute the 4, okay? And I'll get 4x plus 4. And then I'm going to distribute the 3. And I'm going to get 6x. And now I'll move the variable to one side by subtracting 4x on both sides. And I'm left with 4 equals 2x. And my last step is I'll divide both sides by 2. And I get x equals 2. That's how I would solve that problem. Now, let's do one more example. So we're over here, and we're looking, right? We have 3 and 27. They don't have the same base. But I know that I can write 27 with a base of 3 because 27 is 3 to the third power, right? 3 times 3 is 9, times 3 is 27. So I have 3 to the 5x minus 2 power. And then 27, also written as 3 to the third power, and that's being raised to the x minus 3 power. Notice I didn't change the powers, okay? All I did was rewrite 27 as 3 to the third power. In this example, all I did was rewrite 8 as 2 to the third power and 16 as 2 to the fourth power so that they could have the same base. Now, since I look, and since the bases are the same, they don't mean anything anymore, okay? And I just have to look at the exponents. Okay, if the bases are the same and it's equal, I know the exponents have to be the same. So I'm just going to write the exponent, 5x minus 2. And then on this side, I have 3. And then in parentheses, I have x minus 3. And now I'll distribute on this side. Okay, and I'm going to get 3x minus 9. And over here, I have 5x minus 2. And then I'm going to move the variable to one side using addition or subtraction. In this case, I subtracted because I have a positive 3x. So I'm going to subtract 3x on both sides. And I'm left with 2x minus 2 equals negative 9. Okay. And then I'm going to add 2 to both sides. And I'm going to get negative 7. So I have 2x equals negative 7. And then to solve that, let me rewrite it here. 2x equals negative 7. And to solve, I would divide both sides by 2. So x equals negative 3.5 or negative 7/2. You could write it either way. And that's how you would solve that problem. So the important thing is coming up so that they have a similar base, okay? And then you just have to set the equations equal to each other, but you cannot solve if they don't have a similar base.